So we are operating with polynomials, which just means we are going to add, subtract, and multiply. We will divide, but not today. So we'll get to division, polynomial division later on, but not today. So not today. Okay, so we're going to add and subtract first, and then we're going to multiply. You have done all of these things before. Not to the scale that we have done them, especially the multiplication. We did multiplication last semester to make quadratics, so we multiplied lines times lines, binomials times binomials, and that gave us trinomials, which are quadratics sometimes. So we'll use a couple methods to do each of these things. Addition and subtraction, basically just combining like terms. Multiplication is going to be multiply, make sure we distribute everything to everything, and then combining. Okay, so first example, I don't have for this specifically like notes of defining things or like something really, really new. We're just going to do a bunch of math examples here. All right. So when we're adding and subtracting, you have done things like 3 plus 5 before, vertical math, right? And this would be 8. We can do it vertically. Or, you could do 3 plus 5 horizontally, and that also equals 8. We're going to do this addition and subtraction both of these ways. Okay, this is a good way to keep track of all the terms and not miss anything, but this is normally how we write mathematical expressions, right, horizontally. And so we're going to do both of those. So for my first example, for my first magic trick, that's a 3x cubed plus 2x squared minus an x minus a 7. We are going to add this to x cubed minus 10x squared plus 8. Now you'll notice the stuff in this parentheses, we have 1, 2, 3, 4 terms. And over here we have 3. 1, 2, 3. So not everything is going to combine, but we're just combining like terms. So I'm going to highlight in color the things that go together. Things that go together have the same variable and the same exponent. So this x cubed isn't going to combine with the x squared or the x or the 7, but it will combine with this x cubed over here. So these two are going to go together. And then we have a pair of x squareds. This is going to go with this over here. And we have an x and no x. And then the 7 and the 8 go together. I'm not going to highlight every single problem we do, but I do want to make it clear that like terms combine and we don't have the same number of like terms. Now, let's do this vertically first. So I'm going to write this first thing out again. 3x cubed plus 2x squared minus an x minus a 7. And then I'm going to take this and I'm going to line up the terms so we can just add them vertically. So x cubed here, the 10x squared. There's not an x in the second expression, and then the 8 at the end. And then we're just going to add down. So we're just combining like terms. This is not normally how I would do this kind of problem. How I would normally do it is the next example. But this is a good way to keep track of like terms and not skip anything, which it can be easy to miss a term. Like it's really easy. This is a single minus x. It's really easy to forget it in our answer. So 3x cubed plus a single x gives us 4x cubes. 2x squared minus 10x squared. Well, 2 minus 10 is a minus 8. we just bring down the single negative x. And then negative 7 plus an 8 is just a plus 1. And so this is our answer. Okay, so that's one way to do this. The other way would just be, well, we're going to add the x cubed and x through x cubed and the x cubed, and we get 4. We're going to do 2 minus 10, we get negative 8. We have a negative x, and we have a negative 7 plus a. You just go through the terms and add them together. So we'll do one like that too. 9. Let's do a different variable. M cubed plus 3m squared minus 2m plus 1. Negative 5m squared plus m minus 4. Oh, sorry. There you go. So we could rearrange this to do the vertical addition, but I just want to go through and combine like terms. Did I get all those exponents right? Yep, I did. So does m cubed have another m cubed over here that we're going to combine it with, either addition or subtraction? Nope. So we would just write 9m cubed. And then 3m squared goes with this negative 5m squared. Those two go together. So 3 minus 5 is a minus 2m squared. And then these two go together. Negative 2m plus an m is a minus an m. And then 1 minus 4 is minus 3. Yeah, we could do the arrow there too. So we're just going through each term, each individual piece of multiplication in a variable, checking if it has any like terms in the other function or the other expression, and combining them, combining like terms. This is probably how I would do most problems. This vertical math can help us keep track of each term, each set of like terms, and not skip anything. It's really easy to miss this minus x, just like it's really easy to do like this minus 2m and this m. Forget that, but either way. Any questions on addition so far? Okay. So then we're going to subtract. Oh. Yes, Brian. Yeah, if you put a 1 in here, that's fine. Yeah, so you could put a 1 leading coefficient. You could write 1m if you want, minus a 1m. It's the same thing. Yeah, if it's easier that way to keep track of the minus 2 and the plus 1 here. Yeah, and this like 1x cubed. That's all for you. It's the same. You don't need to write the 1. It's like a redundancy, I guess. But yep. Subtracting polynomials. Ooh, oops. Polynomials is basically the same as adding them, except we're going to have to flip some signs. We're going to need to distribute the negative to all the terms in the thing that we're subtracting. So we're going to subtract 2x cubed. Is it the same function? No, it's not. This thing, and we're going to subtract where'd it go? X cubed minus 3x squared minus 2x plus a 9. There's a number of ways to think about this, but generally we're going to switch to addition by distributing the negative. Okay, so I'm going to do this using the vertical alignment, but we need to distribute this negative to each thing here, so the positives will become negative, so this will be a minus 8x cubed, but this negative is going to become a positive, right? Double negative makes positive, so minus a minus is going to be plus 3x squared plus 2x minus a 9. So we got to distribute this negative to everything inside. But let's do this using the vertical subtraction, minus x plus a 1, and then I'm going to align all the terms, so this becomes 8x cubed, and I'm going to switch every sign, so minus 8x cubed plus 3x squared plus 2x minus 9. So I switched every sign because we're subtracting, so I distribute this to every term inside here. And then when we add down, we'll get our combined polynomial. So 2 minus 8 is negative 6x cubed. 6 plus 3, 1 minus 2, or negative 1 plus a 2 is plus a single x. And 1 minus 9 is minus 8. And we have our new polynomial. The combination of whatever these values were minus whatever this value is, which is another way to think of it, is we have our whole polynomial. We're subtracting this one, and you would get a new polynomial with a new shape. If we were to graph them, which we will do eventually, but not for a while. Okay, one more subtraction one. Q. Okay, so now I'm not going to do that vertical transformation. I am going to distribute this negative in here. So we get 3q squared plus q minus 4 minus 2q minus the 3q. So both of these become minuses. Distribute the negative. And then we just need to combine like terms. So 3q squared minus a 2q squared gives us a single q squared. A single q minus 3q is going to be a minus 2q's. And then we're just left with the minus 4. And so this would be our combined simplified polynomial expression. Did I forget something? No. Oh, I see. All right, so that's addition and subtraction. I think that's just a review of combining like terms. Same variable, so we can combine them. Same number of variables, so same exponent, we can combine them. And you just add and subtract the coefficient, the number in front. All right. Any questions on subtraction or addition before we move on to multiplication? get cold. That gets cold fast. All right, so I'm going to flip this over, and we're going to talk about multiplication. All right, before we do an example, I want to remind you, well, it's just another example, remind you of our area model or our Punnett square that we have used to multiply binomials, because that's going to be helpful. Your textbook doesn't use this method to multiply, but it's perfectly good methodology, which might even be better, right? So say we wanted to multiply, I guess this is just example one, whatever. X minus 3 times x plus 2. This is really review. The multiplication that you're going to be asked to do for this unit is going to be generally larger than x minus 3 times. This is going to expand into a quadratic. We're going to be multiplying bigger things together. But the way that I would do this, there are two ways. We're going to do our area model over here, and over here we'll just do distribution. Either way works. This way is probably faster, less writing. This way is probably more consistent. So just decide for yourself which you think is best. Okay, so I have set up the outside first. We've done the purple part first. And then we're going to, color green, I guess. We're going to multiply each side of the box to get the inside. And we did this, before Thanksgiving or something, last semester. I'm just going to multiply everything. And that will be our multiplication here, right? We're multiplying x minus 3, which is this top side, times x plus 2, which is this left side. So we get x squared. Negative 3 times x is minus 3x. X times 2 is 2x. Negative 3 times 2 is negative 6. So we're going out to n when we multiply. When we factor, we go the other way, but we're not factoring yet. Okay, so then we get x squared minus 3x plus a 2x minus 6. All the things in the box get added together, which is really just x squared minus an x minus a 6. Okay, so that would be the area model, where we use the box to multiply to find what the multiplication is. So we multiply the sides to find the area of the box, which tells us the values for the multiplication. Now, what we're going to do for bigger polynomials is we're just going to make bigger boxes. Okay, but there's another way to do this. You can just distribute. Just do x minus 3 times x plus 2. We're going to multiply this x. Oh, gotta close our parentheses. Multiply this x times everything over here. And multiply this negative 3 times everything over here. That'll give us our new problem, and we get kind of this like bird face thing going on. Maybe you can see it. I don't know. Somebody showed me that, and I was like, you're a way better artist than I am, and maybe eyeball helps. All right, so x times this first x gives us x squared. And then x times 2 gives us a plus 2x. So that's this x times everything over here, and then we also need to do the negative 3 times everything over here. So minus 3x, negative 3 times x, minus 3x, negative 3 times 2, minus 6. And then we would combine like terms, so we get x squared minus an x minus 6. We get the same thing, which, thank goodness, that means we did it correctly. Do I care which method you use? Not really. I think one's better. The area model, I think, is going to be the easiest to keep track of things, especially since we're going to be doing things like trinomials. Okay. So, do I want to show you the other way? No. All right. So let's do an actual example like we would see on the homework possibly, or on the quiz. So this is going to be times x minus 3. And we might get bigger than this. So here's what we're going to do. We're going to make a box, and the length of the side is going to be the same as the number of terms here. So this is going to be a 2 by 3 box. So x minus 3 here, negative x squared plus 2x and a 4. Now, I didn't really mean to write plus, but whatever. You could switch this box and make it vertical and do the same thing. It doesn't matter. I think it's just we're very used to reading horizontally. So there you have it. Okay. So we're just going to multiply everything. Every box piece. So minus x cubed. We have an x squared and an x. That makes 3 x's being multiplied. X cubed. 2x squared. X times x gives us the x squared, and we have the 2. And then a 4x over here. Okay, and then we'll multiply everything by negative 3. So we get 3x squared. We get a minus 6x. And a minus 12. Now, if you remember back to last unit, I said that the diagonals are going to combine most of the time. And they do here. So these two numbers are going to add together. These two numbers are going to add together to make like terms. It only, does it work every time? Possibly not, because you might be missing some terms. So like this goes x squared, x, no x. But if you are like missing the single x, they might not add diagonally. I don't want to promise anything that isn't true. So now I'm just going to write the things in the box and combine them. So minus x cubed, I have a 3x squared and a 2x squared. That gives me 5x squared. So that would be these two things. And then the negative 6x and the 4x makes a minus 2x. And then we have a minus 12. Any questions on the bigger box? I don't think I'm going to do a distribution example. It's exactly the same. We're just adding more things to be multiplied. So it's harder to keep track of. I think the box is the best way to do this. But you could also do it by distribution if you wanted to. All right, we're going to multiply something larger, and then we're going to do 3 binomials. 1 3 binomial example. So let's do 2x cubed plus 4x minus 11 times a single x squared minus 5x minus 3. So we have 1, 2, 3 terms and another 1, 2, 3 terms. So our box needs to be a 3 by 3 box. Signs are not straight. And then 2x cubed, 4x minus 11, x squared minus 5x minus 3. Now you'll notice this one skipped the x squared, right? It went x cubed and then a single x. So it skips an x squared, which means we're going to be missing some numbers in our final combination of all the things in the boxes. Okay, so we're just going to multiply the intersections here. So 2x cubed times an x squared gives us 2x to the 5th. And then you could do these in any order. We could do this one next if you wanted. We could do 33 here. Negative 11 times negative 3, positive 33. But really, I kind of like to go like across the boxes. But whatever order you do them in, doesn't matter, right? 4x times negative 5. X is going to give me a negative 20x squared. Just fill in the pieces. The order here doesn't matter. So I'm going to go horizontal the other way. 4x cubed minus 11x squared. So no number here, so it's just a 4 times 1, so 4. And then we have 3x's making x cubed. And then 11 times x squared. And then negative 5x. 10x to the 4th. X cubed times an x gives us x to the 4th. You'll notice our diagonal doesn't work now. These are not going to combine because they're not like terms. And that's because we skipped that x squared. So then it becomes 55x. And then negative 6x cubed. And a minus 12x. And then we have all of our pieces. So now we're just going to combine like terms. And we got to be careful. There are 2x cubes. They're just not diagonal. They're kind of oddly diagonal from each other. We have some x squared, so we have the x's. So I'm just going to go through and we're going to add all those together. I think that means I need that space there. So 2x to the 5th minus 10x to the 4th minus 6x cubed plus 4x cubed. Now you could write them all out, which I guess I'm doing now, but you could also just combine them if you already know that they combine. So minus 20x squared and minus 11x squared. That's going to give us a minus 33x squared. And then we have a running out of room situation going on. But 55x, yeah, I'm going to run out of room, minus a 12x, and then there's a 33. Definitely ran out of room, sorry. But we're just going to combine the like terms. So 2x to the 5th doesn't combine, 10x to the 4th doesn't combine, the x cubes do combine, minus 2x cubed, negative 6 and a positive 4, minus 2. And then 20 and 11, minus 31x squared. 55 minus 12, 43. And then plus the 33. And that would be our new polynomial. Which, yeah, when we multiply things with 3 terms, we're going to get something with a lot of terms. The number of terms here depends on if these like exponents match and if they're all consecutive. Because the first equation here doesn't have an x squared, we skip a column of x squareds, and so it throws things off just a little bit. Any questions on what I did there? The largeness of it, I think, makes it more complicated. Not really that the multiplication is more complicated, it's just that there are more numbers to keep track of. And so I really strongly suggest not doing distribution and just like drawing the arrows and keeping track of everything. just use the box.